Assalamualaikum and a very good day, class. Today we're going to learn a new subchapter 2.4 Ferrous and non-ferrous metals. Here are the learning objectives. At the end of the session, you should be able to differentiate the difference between ferrous and non-ferrous metals, describe the characteristic of white, grey, ductile and malleable cast iron, and understand the properties and application of all the metal and its alloy. Here are the outline of the chapter. We shall learn about some introduction, classification of metal alloys, which is ferrous and non-ferrous alloy. For an introduction, there are two types of metal, which is ferrous and non-ferrous. Ferrous metal basically contain iron as the prime constituent. And there are two types of ferrous metal, which is steel and cast iron. Because of the presence of the ferrum, it tends to have higher chance of corrosion. For non-ferrous metal, it is a metal that contains less or no iron. For example, copper, aluminium, magnesium, titanium, and many more. It has much higher resistance to corrosion. Here are the advantages of ferrous and non-ferrous metal. Ferrous metal tend to have greater strength, excellent toughness, greater stiffness, better for welding purpose, and it has lower cost than some non-ferrous metal. Usually, ferrous metal also have higher availability and abundant in amount compared to non-ferrous metal. While the advantages of non-ferrous metal are it is good corrosion resistant, it is used for casting and cold working, and it is often have high ductility. Non-ferrous metal also contain higher thermal and electrical conductivities, and usually it is differentiated by its colors. Here are the disadvantages of ferrous metal and non-ferrous metal. Ferrous metal tend to corrode because the presence of ferrum inside it. It also have higher density and low electrical and thermal conductivity, while non-ferrous metal has limited quantities. Therefore, it is usually more expensive than ferrous metal. Non-ferrous metal also are non-magnetic and it has limited strength capabilities. Here are the classification of metals. Metals have two types of classification, which is ferrous and non-ferrous. For ferrous metal, we have steel and cast iron. Here are the classification for steel. We have low alloy and high alloy. For low alloy, we have low carbon steel, medium carbon steel, and high carbon steel. And for high alloy, we have tool and stainless steel. There are four types of cast iron, which is grey, ductile, white, and malleable iron. For non-ferrous metal, in this chapter, we shall only concentrate on a few types of non-ferrous metal, which is aluminium, copper, magnesium, and titanium. We will also learn about noble and refractory metals. For ferrous metal, it is differentiated by the presence of ferrum or iron inside the material. It is classified by the amount of carbon in the metal. As you can see in the phase diagram, if the carbon is less than 2.14%, it belongs to steel family. While if it is more than 2.14%, it belongs to cast iron family. So generally, the properties will be depending on the amount of carbon. The amount of carbon also affect the hardness, strength, and brittleness, as all this property will increase with the amount of carbon. By increasing the amount of carbon, the metal will also have lower weldability and ductility. Before we start, I would like to introduce you to a few microstructures that will be present in the metal. Here are the picture or the image of ferrite. Here are the image of pearlite. Okay, as you can see, the pearlite resemble the cabbage cross-section. And here are the structures of austenite. And here are the structures of martensite. And lastly, bainite. I hope you can get some idea on how the microstructures of the metal going to be look like. Let us move on to the first ferrous metal, which is steel. Steel is an iron that contain less than 2.14% carbon. It has high melting temperature that range between 1400 to 1500 degrees C. It is classified by the carbon content, which is low, medium, and high. While there are subclasses of the concentration, by adding the alloying element, you can classify the steel into plain carbon steel and alloy steel. Usually, the microstructures are ferrite and pearlite. Here are the type of steel. As you can see, low alloy steel are differentiated by the amount of carbon. Low carbon, less than 0.15, medium carbon is limited to 0.6%, and high carbon limited to 1.4%. There are two types of low carbon, medium carbon, and high carbon steel, which is plain steel and other types of steel. So what are the difference of this plain steel is actually there are no addition of alloying element into the metals. For alloy steel, we have austenitic stainless steel and also tool steel. You could also look at all the properties such as hardenability, tensile strength, and elongation of these steels. And here are also the usage of all these steel. We shall look into all these properties deeper in next section. In the industries, the steel are designated with numerical and alphabetical designation. For example, 0, 10XX are usually for carbon-only steel. And you can look at below example, SAE 5130 mean it is an alloy with chromium steel containing only 1% chromium and 0.3% carbon. Let us take a look at one type of steel, which is plain carbon steel. It is actually an iron with less than 1% carbon that contains other alloying elements such as manganese, phosphorus, and many more. The disadvantage of plain carbon steel is its low hardenability and strength, and it is also subjected to corrosion in most environments. There are three groups or classification, which is low, medium, and high carbon steel. The first type is low carbon steel. It is actually steel with less than 0.25% carbon. There are two types, which is plain carbon steel and high-strength low-alloy steel. Usually, plain carbon steel has no alloying element and unresponsive to any heat treatment, while high-strength low-alloy is actually low-carbon steel with addition of 10% alloying elements such as manganese, chromium, copper, and many more. The microstructures is also different. Plain carbon steel contain ferrite and pearlite, while HSLA only contain carbide and ferrite. The properties are very much different also, as the plain carbon steel are relatively soft and weak, while HSLA has much higher strength. Both have good formability and ductility, but plain carbon steel have lower cost compared to HSLA. HSLA has more resistance to corrosion and is usually strengthening by heat treatment, meaning to say, by doing heat treatment to the sample, we can increase the strength of the steel. The rate of machinability of plain carbon steel are usually 55 to 60%. Here are also the application of plain carbon steel, which is usually used for auto body component and structural parts, while HSLA is usually for bridges, towers, and any structural application. Next, we have medium carbon steel, which has carbon content of 0.25 to 0.6%. Also, it has two types of classification, which is plain carbon steel and heat-treatable steel. For plain carbon steel, it has less than 1% carbon, while heat-treatable steel has addition of manganese, nickel, and molybdenum. The microstructures in plain carbon steel are ferrite and pearlite, while after heat treatment, the microstructures will turn into martensite, bainite, and sporudite. Plain carbon steel has good toughness and ductility, while after you heat treated the sample, it will lower the ductility and the toughness. But heat treatable steel has higher strength than plain carbon steel. The rate of machinability increased compared to low carbon steel, which is 60 to 70%. The application of plain carbon steel are usually crankshaft, bolt, hammer, and blade, while after you heat treated, it becomes stronger and it will be used for piston, gear, and wear applications. Lastly, we have high carbon steel, which has carbon content of 0.6 to 1.4%. Also have two categories, which is plain carbon steel and tool steel. For plain carbon steel, it has less than 1% carbon, but tool steel addition of 10% chromium, tungsten, molybdenum, and vanadium. The microstructures of plain carbon steel are pearlite, while the microstructures of tool steel are martensite, carbide, and austenite. The properties difference are plain carbon steel has high strength, less weldability, and less formability, while tool steel have higher wear resistance, higher hardness, but low ductility and machinability. Plain carbon steel are usually applied for coupling, gear, and crankshaft, while tool steel it is used to make drill, saw, dies, and also blade. Another type of steel is high alloy steel. It is a steel with addition of 8 to 20% alloy. It has two types, which is tool steel and stainless steel. For tool steel, different from plain carbon steel, it has addition of 8 to 20% alloying element that produce excess carbide, which make them more hard and more wear resistant. While in stainless steel, it is actually steel with addition of 10 to 18% chromium and other alloys such as niobium, silicon, nickel, and magnesium. For stainless steel, it will develop a thin, hard film called as chromium oxide that help protect the metal from corrosion. The microstructures are carbide and martensite for tool steel and austenite, ferrite, and martensite for stainless steel. The properties of tool steel are as before, which is high strength and wear resistant, while in stainless steel, it is known for its high corrosion, high strength, and shiny appearances. Application of tool steel usually for cutters, reamers, and beads, while for stainless steel, it is used for ornament, pipe, gating, and also culinary application. Now we move on to another type of ferrous metal, which is cast iron. Cast iron has carbon content of 2.14% to 4.3% and silicon content of 0.5% to 3%. And the addition of silicon are usually used to control the kinetic of carbide formation so that the graphite form could be formed into desired shapes. Cast iron has lower melting temperature compared to steel, which is 1150 to 1400 degrees Celsius. The microstructures are usually consist of graphite surrounded by pearlite and ferrite. So the difference between cast iron and steel is the carbon content, and also silicon content and the carbon microstructures. The properties of cast iron could be controlled with these factors. The first one is chemical composition of the iron, which is basically the amount of carbon, and the rate of cooling of cast iron are usually much more faster than steel, and also the type of graphite formed. Here are the advantages and disadvantages of cast iron. Cast iron have good formability and liquidity, and is usually readily to be cast into any complex shapes because of the properties above. It also have high vibration and damping properties, excellent wear resistance and hardness, and low tooling cost. The disadvantages of cast iron are it has low strength than steel. Usually it is prone to external and internal corrosion, low yield point, and brittle than steel. There are four types of cast iron, which is grey, ductile, white, and malleable cast iron. Grey cast iron has carbon content of 2.5 to 4% and silicon content 1 to 3%. Usually, the microstructures are graphite that are surrounded either by ferrite or pearlite faces. The properties are less hard and brittle, so it is easy to be machined, very weak in tension, and it has lower strength than other type of cast iron. It has high damping capacity and low melting temperature. Usually, it is applied as a base choice for milling machine because it would be able to absorb more vibration during the machining process. Shown here are the microstructures which consist of graphite in the flake forms. Here are nodular cast iron, which is actually cast iron with addition of manganese and cerium. And what it do is it turn the graphite into nodular or round form. And it has significant increase in the material ductility because the graphite has turned into spherical form, and it has higher tensile strength than grey cast iron. Other mechanical properties are quite similar to steel. It is applied as valve, pump body, gear, and many more. And as you can see, the graphite is in nodular form. Next are white cast iron, which is actually cast iron with carbon in between 2.5 to 4% and silicon less than 1% composition. And it consists of pearlite and cementite microstructures. The difference with other types of cast iron is this type of cast iron undergo rapid cooling. So it became very hard and brittle and is not weldable compared to any other types of cast iron. It has excellent wear resistance, and after it annealed, it will turn into malleable cast iron. So different from other cast iron, where it has graphite. So this type of cast iron consists of cementite. It is applied as slurry pump, ball mill, lifter ball, and many more. And lastly, we have malleable cast iron. It is actually heat-treated white cast iron. So the process starts by heating white cast iron at temperature of 800 to 900 degrees C for a duration of at least 50 hours or 2 or 3 days. And the heating environment are inside a furnace in neutral atmosphere. So the result are a clump or rosette. Okay, as you can see, the graphite are in rosette. It looks like a rose. Okay, and this is due to the decomposition of cementite. And of course, it is also surrounded by pearlite and ferrite. The properties are quite similar to nodular cast iron but higher strength. And it also have more ductility and malleability compared to grey cast iron. It is applied as pipe fitting and also mainly used for railroad application. Okay. As a summary, as you can see, the addition of carbon and any other processes such as heat treatment and also the cooling rate would give different types of cast iron. Thank you, and that is all for this chapter.